Hello friends, I welcome you in lecture number 18 on partial derivatives. In previous two lectures, we have defined gradient and directional derivatives of a scalar function. And in this lecture, we are going to discuss one more problem on computation of directional derivatives. So before going for today's problem, we recall one thing that we will require in the problem which we are going to discuss today. Suppose we consider this xy plane, this is x axis, this is y axis, and suppose this vector u bar is having components xy or xi plus yj, and suppose this angle made by this unit vector with positive x axis is theta. Then we know that if we complete this right angle triangle, then we know that if u bar is xy, then this distance is x and this distance is y. And if this length of u bar is r, then we know that cos theta is x divided by r and sin theta is y divided by r. Or we can write x as r cos theta and y equal to r sin theta. So these components of u bar can be written in polar form as r cos theta times I plus r sin theta times j. If we consider this in this form xi plus yj, and we put x equal to r cos theta, y equal to r sin theta, then our vector u bar can be rewritten in this form also. Now suppose u bar is unit vector, then length of u bar, that is r, will be equal to 1. So if u bar is unit vector, then u bar can be written as cos theta I plus sin theta j, where theta is the angle made by vector u bar with positive x axis. So sometimes in the problem of directional derivative, you will not be given vector u bar directly, but they will say that u bar is the unit vector given by angle theta. So we will remember that unit vector given by angle theta can be written as cos theta I plus sin theta j, where theta is the angle made by vector u bar with positive x axis. So with this in mind, we try to complete today's problem. So here I have written this note: the unit vector u bar which makes an angle theta with positive x axis is given by u bar equal to cos theta I plus sin theta j, or we can write as a order pair cos theta sin theta. So with this in mind, we try to complete this problem. This question was asked in GTU Summer 2019 examination. Here we are asked to find out directional derivative if this scalar function is x cube minus 3xy plus 4y square and u bar is the unit vector given by angle theta. So first we have to write down the formula for directional derivative of this function at any point xy, and then we have to calculate directional derivative at this particular point 1, 2. So as we have discussed in the last lecture, that directional derivative can be obtained by taking dot product of a given scalar function with given unit vector. So this we are familiar from the last lecture. So first we have to find out gradient of this scalar function, and then we will take dot product of gradient of this scalar function with this unit vector. Now here unit vector is given by angle theta. So first we write down, as we have discussed, the unit vector given by angle theta, that is unit vector which makes angle theta with positive x axis, is given by u bar equal to cos theta I plus sin theta j. Now here angle theta is pi by 6, so we put theta equal to pi by 6. Therefore u bar equal to cosine of pi by 6 times I plus sine pi by 6 times j. And we are familiar with this standard angle values of cos and sine. Cos pi by 6 is square root of 3 divided by 2 and sine pi by 6 is 1/2. So this is the unit vector and we have to compute directional derivative in the direction of this unit vector. So here unit vector is not given directly, but it is written that unit vector given by angle theta equal to pi by 6. So we will remember this remark that unit vector given by angle theta is cos theta I plus sin theta j. Now rest of the things are familiar with us. We find out gradient of this scalar function. So first we write down scalar function x cube minus 3xy plus 4y square. X cube minus 3x square y plus 4y square. Let me check again. It is x cube minus 3xy plus 4y square. It is 3xy. So first I write down given scalar function and I have to find out partial derivatives with respect to x and y. So for del f by del x we consider y as constant. So derivative of this term is 0. Derivative of x cube is 3x square. Here minus 3y is constant. Derivative of x is 1. And partial derivative with respect to y. So we consider x as constant. So this term becomes constant. Its derivative is 0. Here minus 3x is constant. Derivative of y is 1. And derivative of 4y square is 4 into 2y, that is 8y. So now therefore we can write down the formula for gradient of f is del f by del x at point I plus del f by del y at point j. So we write down 3x square minus 3y times I plus minus 3x plus 8y times j. So this is the gradient of f at any point xy. So first we have to find out directional derivative of f at any point xy. So for that we take dot product of this unit vector and this gradient vector. So now by the formula of directional derivative at any point xy in the direction of unit vector is gradient of f at any point xy dot product with unit vector u bar. So we have to take dot product, so we have to multiply corresponding components. So we write one more step. First we write down gradient of f 3x square minus 3y times I plus minus 3x plus 8y times j, and we have to take dot product with unit vector which was root 3 by 2I plus 1/2 j. Let me check this. It is root 3 by 2 1/2. So now we multiply corresponding components. So 3x square minus 3y times root 3 by 2, or we can write root 3 by 2 times 3x square minus 3y plus minus 3x plus 8y times 1/2, that is 1 by 2 minus 3x plus 8y. So this is the formula for directional derivative of a given scalar function at any point xy in the direction of unit vector u bar. So we have completed this first part, find the directional derivative at any point xy. Now using that formula of directional derivative, we have to calculate directional derivative at point 1, 2. So for that we put x equal to 1 and y equal to 2 here. Therefore directional derivative of f at point 1, 2 in the direction of u bar equal to root 3 by 2. we have to take x equal to 1. So x square is 1 minus 3 into 2, that is 6, plus 1 by 2, x is 1, so we have minus 3 into 1 minus 3 plus 8 into 2, that is 16. So this we can rewrite as root 3 by 2 into minus 3, and this is 13. So we can take 1/2 common, and this we can rewrite as 13 minus 3 root 3. Okay, fine. So here I have to write down under root 3. So this is the directional derivative of a given scalar function at point 1, 2 in the direction of unit vector. Okay, if you wish you can find out this value by using scientific calculator, otherwise you can keep it as it is. This is the answer for directional derivative at point 1, 2. Okay, so this is all about this session. I hope you understand this. What is new thing in this problem is that unit vector is given by angle theta. So we have used this formula for unit vector, which makes angle theta with positive x-axis. Otherwise things are as usual. We are taking gradient of f, dot product of gradient of f and unit vector to compute directional derivative. So this is all about this session. I hope you like it. Thank you very much.